Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Actually, I am reviewing the first chapter, that is a concept of chemistry. Now I am reviewing, and after the reviewing entire chapter, I will discuss many questions, multiple choice question, numericals, and several type of question that is asked in different pattern. I will discuss. Okay, then now I am going to discuss mole. Many things are there. All things I will discuss in a brief way. It is actually reviewing. I am reviewing so that you can solve the question. Okay, for that purpose I am reviewing the first chapter based on atoms, molecules. Many formulas are there, laws are there. All you should know before solving the questions, different type of question. Then now I am telling about the mole. Mole is very important concept. Many numericals you have to solve on this concept. Then what is actually mole? I am briefing you. In case of atomic substances, 1 mole is equal to gram atomic mass or 1 gram atom of the element. 1 mole in case of atomic substances, you remember, in case of atomic substances, 1 mole is equal to gram atomic mass or 1 gram atom of the element, and that is equal to 6.02 into 10 to the power 23 atoms. This is called Avogadro number. Means 1 mole is equal to Avogadro number. Means 6.02 into 10 to the power 23. Means 1 mole is equal to gram atomic mass or 1 gram atom of the element, and that is equal to 6.02 into 10 to the power 23 atoms. Okay, in case of atomic substances. Now second, in case of molecular substances. In case of molecular substances, 1 mole is equal to gram molecular mass or 1 gram molecule, that is equal to 6.02 into 10 to the power 23 molecules. That is also called Avogadro number. Correct? When you are talking in case of atomic substances, then Avogadro number you can tell atoms. 6.02 into 10 to the power 23 atoms. When you are talking in sense of molecular substances, then Avogadro number you can tell in term of molecules. Means 1 gram mole. It is similar to atomic masses. Okay, here you can tell gram molecular mass. 1 mole is equal to gram molecular mass or gram molecule, 1 gram molecule, and that is equal to 6.02 into 10 to the power 23 molecules. Correct? This is also called Avogadro number. Avogadro number in terms of atoms and other in terms of molecules. In case of molecular substances, it is a Avogadro number you can tell in term of molecules, and in case of atomic substances, Avogadro number you can tell in atoms. Now third, one more thing here, 1 mole that is also equal to 22.4 liter. 22.4 liter at STP. If the substance is a gas, you remember, if a substance is gas, then 1 mole is equal to 22.4 liter at standard temperature and pressure, STP. If the substance is gas, okay, and this is also called gram molecular volume. This 22.4 liter at STP is also called gram molecular volume, GMV, gram molecular volume. Now third I am talking about in case of ionic compounds. In case of ionic compounds, 1 mole equal to gram formula mass of the compound. 1 mole is equal to gram formula mass of the compound, and that is equal to Avogadro number formula units of the compound. Okay, all are similar. 1 mole is related to first number. 1 mole is related to number. 1 mole is related to mass also. And third, 1 mole is related to volume also. It correlates. Mole correlates 3 things. First, number. Second, mass. And third, volume. You remember. It means if you are knowing mass, you can know the volume. And if you are knowing the volume, you can know the number also. If you are knowing number, then you can tell mass. If you are knowing mass, then you can tell the volume or other two. If one you are knowing, other two you can know. How? Because all are equal to 1 mole only. 1 mole is related to mass, 1 mole is related to volume, 1 mole related to the number. Correct? Hence, any one you are knowing, the all are interconnected. You can know the others. Then like that way here, I am talking you in case of ionic compounds, cation and anion, like NaCl, KCl, KCl, calcium sulfate, copper sulfate. In that you are seeing cation and anions are there. In that case, 1 mole is equal to gram formula mass of the compound, and that is equal to 6.02 into 10 to the power 23 formula units of the compound, and that is equal to 6.02 into 10 to the power 23 times the number of atoms present in 1 formula unit of the compound. Okay, 6.02 into 10 to the power 23 times the number of atoms present in 1 formula unit of the compound. As for example, suppose you are talking about the sodium sulfate, Na2SO4. Then in Na2, first its molecular mass, total molecular mass of Na2SO4 you can calculate. Correct? Then that is a 1 mole molecular mass or molecular weight. Okay, anything you can tell. Exact is the molecular mass is correct nowadays. Okay, then molecular mass of Na2SO4 you can calculate, sodium sulfate. Then now if you want to know there how many atoms of sodiums are there, if you want to calculate, then first you have seen in 1 mole of sodium sulfate, two atoms of sodiums are there, Na2. 2 atoms of sodium atoms are there, 2 atoms. Then now, Na2SO4. Then this is the 1 mole. In 1 mole means Avogadro number. Then here sodium, if you want to know the total number of, you can say, atoms of sodium, then now you have to multiply by Avogadro number, 2 into Avogadro number, 2 into capital Na. Na means Avogadro number. Okay, means whatever the numbers are there, in that you have to multiply Na2. Hence total number of atom will be of sodium 2 into Avogadro number. Correct? Like that way H3PO4. H3PO4. Then here again you will calculate the molecular mass, that is equal to 1 mole. Then in that now H3PO4, 3H is there, and total number of H will be 3 into Avogadro number. Like that way H3PO4, O4. If you want to calculate, want to know oxygen atom, total number of oxygen present in H3PO4, then 1 mole molecular mass is equal to Avogadro molecular mass is equal to 1 mole. Correct? And 1 mole is equal to Avogadro number. Then here 4 oxygens are there, O4. Then here 4 into Avogadro number. That is the number of oxygen atom present in H3PO4. Like that way you can calculate. Then this I have told you about the mole. Avogadro number already I have told you, but again I want to just to repeat it. What is the Avogadro number? It is the number of atoms present in 1 gram atom of an element, or the number of molecules present in 1 gram molecules of substance. Correct? 2 things I told you. It is the number of atoms present in 1 gram atom of the element, gram atom, or the number of molecules present in 1 gram molecule of the substance. Okay. In general, it is the number of particles present in 1 mole of the substance. If you are not knowing whether it is a atom or molecule, only Avogadro number you want to tell you, then that time don't tell atoms, don't tell molecules. Okay, you tell only particles. Actually, mole concept you should remember very clearly, that it is a number of any things. Avogadro number, any things in Avogadro number, that is equal to 1 mole. Maybe electron in this number. Electrons in this number, that is also 1 mole. Proton in this number, Avogadro number in this number, that is also 1 mole. Correct? Electron, proton, neutron in this number, that is also called 1 mole. Any things in this number. If you have pen in this number, that is also 1 mole pen. If you have pencil in this number, 1 mole pencil. If you have 10 rupees coin or 1 rupees coin in this number, then 1 mole of 1 rupees coin. Correct? If you have 10 rupees notes in this number, 1 mole of notes, 1 mole of 10 rupees note, or 100 rupees note, or 500 rupees note. Means this is the number. You remember, don't forget. Okay, it will apply for all, but here in chemistry, it will apply for atom, molecules, electron, proton, neutron. Okay. Then this I told you about the Avogadro number. Now next I want to tell you about equivalent weight. Equivalent weight. What is the equivalent weight? Here I want to tell you, many students will get confused in equal and equivalent weight. Both are different. Equivalent means not equal. Equal in some sense, not in all sense. equal in one sense, at least one sense. Okay, that is called equivalent, not in all sense. Simple example I am telling you so that you will not confuse. Now suppose a degree, bachelor degree, BA, Bachelor of Commerce, BCom, Bachelor of Science, BSc, Bachelor of Medicine means MBBS. MBBS name is big, don't confuse. This is the Bachelor of Surgery and Bachelor of Medicine. This is also bachelor degree like a BA, BSc, BCom. Okay, like that way LLB, also bachelor degree. Correct? Then all are in the sense of degree, all are bachelor, but their values are different. Arts have different meaning, commerce has different meaning, science has different meaning, medicine has different meaning, even engineering, BE, BTech, all are equivalent. All degrees are equivalent, but equal in the sense of only degree, that all are bachelor, but their meaning is different. I think now it might have cleared that equivalent means equal in some sense, not in all sense. And now you will understand the equivalent weight. See, you might have seen that this equivalent weight of acid, equivalent weight of acid is means acid will neutralize the base. Acid will neutralize the base. Then 1 gram equivalent of acid neutralizes the 1 gram equivalent of base. Then acid and base both are equivalent but not the same. Acid has other character, base has other character, but both are neutralizing. Then in one sense, in the sense of neutralization, it is equal, only one sense. But acid is different, base is different, both are opposite character. Then like that way always you understand, or very in a simple way. Suppose any strong person is there, very healthy person, and very strong, that it can defeat 2-3 person simply. Then 3% strength is equivalent to 1% strength, a strong person. One strong person, healthy person can see 3 weak person. Then 3 weak person is equivalent to 1 person strong. I think now you might have understood. Then equivalent weight I am talking about. The equivalent weight of a substance is the number of parts. The equivalent weight of a substance is the number of parts, maybe 1, 2, 3, 4, 5, this type of number. The equivalent weight of a substance is the number of parts by weight of the substance that combine with or displace directly or indirectly 3 things. 1.008 part by weight of hydrogen, or 8 part by weight of oxygen, or 35.5 parts by weight of chlorine. You remember, this is the standard definition. Okay, 3 you have to compare, you can tell equivalent in chemistry in terms of 3. First is that the equivalent weight of a substance is the number, you remember, it is the number of parts by weight of the substance that can combine with or displace directly or indirectly. First, 1.008 parts by weight of hydrogen. Now in terms of hydrogen you are knowing 1.008 parts by weight of hydrogen. Second, 8 parts by weight of oxygen. And third, 35.5 parts by weight of chlorine. all three are very, very reactive. That's why that is compared with hydrogen, oxygen and chlorine. Okay. Then this is a number, don't forget. Equivalent weight of a substance is the number of parts by weight of the substance that can combine with or displace directly or indirectly. How? The three things. It can react with three things: hydrogen, second oxygen, third chlorine. Then hydrogen 1.008, oxygen 8 parts by weight, and chlorine 35.5 parts by weight of chlorine. Okay. Hence you can write in a term of formula, you can write that equivalent weight of an acid. Here, before going to this, I want to tell you that this I told you 1.008 parts by weight of hydrogen and 8 parts by weight of oxygen and 35.5 parts by weight of chlorine. Then any substance which can react with 1.008 gram hydrogen, then that substance will be equivalent to this hydrogen. Okay, that will be the equivalent mass of that substance which can react or which can displace 1.008 gram hydrogen, either directly or indirectly. Second, weight of the substance which can react with 8 gram oxygen. Then that substance, how much substance is reacting with 8 gram of oxygen? That weight is equivalent mass. Correct? Third, the weight of the substance which can react with chlorine, 35.5 parts by weight chlorine, then that weight or mass is called equivalent mass, because that substance can react with either with hydrogen or with oxygen or with chlorine. Substance will, there is possibility that they will react at least with any one. Then that you remember, weight which can combine with hydrogen, oxygen and chlorine, with anyone. Okay. Then that is the equivalent mass. Don't forget 1.008 in case of hydrogen, 8 gram by in case of oxygen, 35.5 in case of chlorine. Now equivalent weight of an acid. That is what is this equivalent weight of an acid? You remember in term of formula, that is the molecular weight of the acid divided by basicity. And reverse of this, equivalent weight of base, that is equal to molecular weight of the base divided by acidity. In case of acid, is to divide by basicity, and in case of base, is to divide by acidity. Then what is acidity and basicity? Then see, HCl, acid, HCl is the acid. Then how many H is there? Only one H. In H2SO4, sulfuric acid, how many H is there? 2 H is there. Then here, in case of HCl, its basicity is 1, because only one hydrogen is there. Number of replaceable hydrogen, that is called basicity. Then in case of hydrogen, 2, H2SO4, 2 H is there. Then basicity is equal to 2, replaceable hydrogen. And H3PO4, phosphoric acid, its basicity is 3, because 3 hydrogen can replace. Correct? Hence, equivalent weight of an acid is molecular mass of that acid. Easily you can calculate the molecular mass, just to add the atomic weight for all. That is the molecular mass, and divide it by the number of hydrogen. Means per hydrogen you have to calculate. That's why you have to divide by that number. Then per hydrogen, replaceable hydrogen. Hence, equivalent weight of an acid is equal to molecular weight of the acid divided by basicity. Similarly, equivalent weight of base is equal to molecular weight of the base divided by acidity. Here acidity means replaceable OH ion, hydroxyl ion, replaceable OH ion. Then NOH, only one OH is there. Hence, its acidity is 1 because one OH is there. Calcium hydroxide, CaOH whole 2, its acidity is 2 because 2 replaceable OH ion is there. And in case of AlOH whole 3, 3 replaceable OH is there. Hence, its acidity is 3. Hence, we want to calculate equivalent weight of base. Then, just divide it by, in case of NOH, divide by only 1. In case of calcium hydroxide, barium hydroxide, calcium hydroxide, whatever be number of OH, replaceable OH, then you divide by 2 if 2 OH is there. And if it is 3, then equivalent of base, the right molecular base divided by 3 if 3 replaceable OH ion is there. Okay. Then this I told about the acid and base. Similarly, equivalent weight of salt. Equivalent weight of a salt. How will you calculate? Then again, easy way. Molecular weight of acid. Molecular weight of the, you are calculating molecular weight of salt. Salt, you remember. Then molecular weight, equivalent weight of salt is equal to molecular weight divided by total positive of the metal atoms. Means you take this molecular weight of salt, correct? As for example, NaCl, then 23 plus 30.5, 23 plus 35.5 divided by how many positive charges there? Then here Na plus only 1 is there. Then divide by only 1. Correct? Only 1. And if it is suppose copper sulfate is there, Cu plus plus, SO4 2 minus. Then just you calculate this molecular weight of the salt and divide it by 2. Correct? Divided by 2 because copper has 2 positive charge. Similarly, calcium carbonate. Then calcium carbonate you calculate the molecular mass. Correct? And after that divide it by 2 because calcium has 2 positive charge. Then formula became like that: molecular weight of the salt divided by total positive valency of the metal atom or ion, you can tell. Now same way equivalent weight of an oxidizing or reducing agent. How will you calculate? This is again very very important. Equivalent weight of an oxidizing or reducing agent. Then you know that oxidizing agent and reducing agent, it is related to number of electrons. Correct? Substance which can donate the electron. Correct? That is the process of oxidation. Loss of electron, that is the oxidation. Then here how many electrons it is losing? How many electron it is losing? Correct? In oxidation process, how many electron it is losing? And in reduction process, reverse of this, how many electron it is taking? Correct? In a reaction, you know that oxidation and reduction takes place together simultaneously. One will lose, other will take. Then how how many electrons they are losing or gaining. That number of electron is important. Correct? Then for the oxidation, substance which is responsible for oxidation, that is called oxidizing agent, and substance which is responsible for reduction, that is reducing agent. For the oxidation purpose, someone should be there who can take the electron, then that substance will be oxidizing agent. Suppose A is losing electron and B is taking, then B is oxidizing agent. Similarly, now suppose this B is taking electron and A is losing electron. Who is taking electron? Then B is taking electron. Then this is a process of reduction. Then for this reduction, who is responsible? Who is losing electron? Then A is losing electron. Then for the reduction, A is responsible. Then A is called reducing agent. Understood? Means actually substance which is responsible for the oxidizing agent, oxidation process, that is called oxidizing agent, and which is responsible for reducing agent, reducing reduction process, that is called reducing agent. Then A plus B, then B is oxidizing agent and A is reducing agent. Okay. Then now equivalent weight of an oxidizing or reducing agent in formula way you can understand. Molecular weight of the substance. Always molecular weight you are writing in the top. Okay. And down what you are writing, then this denominator, numerator you are writing always, in numerator you are writing always molecular weight or molecular mass, and denominator what you are writing, always you will write, this will change. Then in this case equivalent weight of oxidizing or reducing agent, here you have to divide it by number of electrons gained or lost by one molecule. Number of electrons lost or gained, something will happen by one molecule. Then molecular weight of the substance divided by number of electrons gained or lost by one molecule. Means here you have to consider per electron mass, that is actually called equivalent weight of an oxidizing agent or reducing agent per electron, because you are dividing by the number of electrons gained or lost. Correct? Then per electron actually you want to calculate. That is the equivalent weight of an oxidizing or reducing agent. Okay. Very simple formula, molecular weight of the substance divided by number of electrons gained or lost by one molecule. Now basicity meaning already told you. Basicity is the number of displaceable H-ions from one molecule of the acid like HCl. Here basicity is 1 and 2 for sulfuric acid H2SO4 and 3 for phosphoric acid H3PO4. Like that way, acidity is the number of displaceable OH ions from one molecule of the base, like 1 for NOH, 2 for calcium hydroxide and 3 for AlOH whole 3. Okay. Then today I am stopping only here. Again next class I will continue. Okay. Thank you.